Hello. I hope you can see me and you can hear me. If you can't, please say so in the chat. If you can, also please say so. The next webinar about object-oriented programming. This is webinar 36. There's so many of them. 3 dozens has already been done, and most of them were dedicated to object-oriented programming. This one is also about that, and I will try to keep it as educational as possible. And the subject is quite simple and I would say even primitive, but which is global variables. But when I was writing a blog post about that just a few weeks ago, I thought that that is so simple, it's so primitive, so obvious to everybody, to all of my readers, that there is no big point of actually, explaining it again on the blog. And I was expecting a complete, a complete silence as a response to the blog post and to my question on Twitter. I made a poll on Twitter. I do, this Sunday polls on Twitter where I collect opinions from my readers, and that was the question for the global variables. I asked the question, what do you think about global variables in object-oriented programming? And there were a number of options, and then the option number 1 was we never use them. The option number 2 was sometimes they're fine, so we use them sometimes, and then the last 2 options were like, who cares, and I can't live without them. So if you summarize the answers, you will see that less than half of my readers, less than 50% of them, actually strongly believe, like I do, that global variables is something we cannot tolerate in object-oriented programming, in object-oriented code, if we want that code to look good. So which was a very big surprise to me. I wasn't expecting that situation. I was expecting like a few percent saying that global variables are good things, because those people are like, maybe uneducated, maybe not professional, maybe just junior programmers, I don't know. But I was expecting the majority of them to say that global variables are evil, which didn't happen. So that's why this webinar, that's why I decided to reiterate on this topic and make it vocal, my opinion about that. Maybe that will help you to understand the problem. I will show you some code, not too much, not a lot of code today, because there's no point of demonstrating a lot of code, but still there will be something to show. But first I'll start with, speaking a little bit without the code. Let me make myself a little bit bigger. So I wanted to say first a few words about object-oriented programming, how I see objects there, and you most probably know my opinion about that from the Elegant Objects books, which I wrote and published, and where I'm saying that objects are like living organisms, living creatures inside our code. And our job as programmers is actually to keep them that way, to keep them look and behave like something which is alive. And when something is alive, then this something has borders, has a body, and the life of this creature happens inside the body. So if it is an object which is called file, then the life of this file happens inside the body of the object. If the object name is a cookie or a proxy or an HTTP page, then inside those objects they live, they behave, they control their data, they do something, but all that happens inside them. That's the whole idea of object-oriented programming, if you ask me. How we can place the code, the actual, the actual execution instructions, the statements inside those objects is the art of programming. So the better programmers we are, the more effective, the more obvious, the more logical, the more elegant is the way we separate pieces of code into objects. So that's why actually one of the most difficult tasks, one of the most important job when you create a new piece of object-oriented software is to find names for your classes and for your methods. When I start writing something new, I always spend a lot of time, like sometimes days, to invent the names for my classes. And the better the names are, the easier for me is to develop the code after that. And if I don't pay enough attention to the names, then the rest of the code is not, well, the rest of the time I spend on coding will not be will not give me the satisfaction. I'm not going to be happy about the code. I'm not going to like that. So the biggest issue and the biggest goal and the biggest objective and the biggest problem is how you define, how you segregate your pieces of code and pieces of data into so-called blocks or entities, which we call objects. And it's very important to keep everything inside. That's what encapsulation is about. So when you decide to put your logic inside an object, then you decide not to allow everybody else to touch that. So it's more about saying no than about saying yes. It's more about rejection than about inclusion. It's more about exclusion than inclusion. So you make a decision what to exclude from your object. This is the most important decision versus what to include. So you need to say what your object is not going to do and what your object is not going to allow other objects to do with it. Each public method you have in your object is the point of access, is the entry point to the object, and you need to be very careful when you define them. The less you have entry points, the less public methods you have, the better is your object. The less ways you give to other objects to use your object, the better. So if you can use you in 3 possible ways, that's one story. If they can use you in 50 different ways, it's a completely different story. It's a totally wrong design if you let other objects to do multiple things with your object. You need to think, exclusively. So you need to think about what you will not allow them to do with you, and then you will stay with what you allow them to do. And that list has to be short. This is what encapsulation is about. Maybe these things are maybe too philosophical, but we need them to understand global variables. An object includes stuff which is data and code. They go together. There is some data, there is some code, and it's sometimes difficult to say which one is which. So we used to think that data is attributes and code is statements of lines of code. But if you think deeper, this decision is made by the object itself. When you design an object, you don't focus on that decision. You focus on what your object is going to do and allow to do for external, for its neighbors. And then what happens inside an object, that will be something an object will decide. So look at this object which is full, but let's call it, for example, user. It's Ruby. It's simple language. And then we say name. We can do it like this. So this is the public method, the public method name. Let's say I do this one. This one is data. This one is code. Let's put it this way. But it's difficult to say actually which one is which, because this one is generated on fly, or is it stored in memory, or it's in stack. We don't really know. It depends on the implementation on the language. And what happens if I do it this way? This is a constructor. So when the object is constructed, I encapsulate George as a name into the attribute. Because of this @ sign, it means it's an attribute. And then here I returned an attribute. So what's the difference between between this method, which returns some data on fly and generates this data somehow on fly. So most probably it's stored in stack, not in heap. But here we return something from heap. So which data, which can we actually draw a very clear line between the code and the data? I don't think it's necessary, and I don't think it's really important. What's important for us is that when I instantiate an object and I say user age, here on the surface I receive the age, which is data, of course. When it flies out of the method, then it's data. But what happens inside an object, I don't really know whether this data was encapsulated, whether it was generated on the fly, or maybe whether there is no data and maybe, I don't know, maybe an exception goes from there or something else. So the point is that internal structure of an object, let me check whether you see my screen. Yeah. So the point is that the internal structure of an object, internal logic which goes into the object, is not really important for its neighbors. And when we design an object, we make the decision of what's going to be the surface. So here the surface is name and age. This is the surface of the object. This is how we interact with it. What's inside is encapsulated. We encapsulate data, and we also sort of encapsulate the code. Even though this term is not used for the code, in most cases when we say encapsulate, we mean the data. But here the question is, do we encapsulate 34? According to the traditional definition of object-oriented programming, we do not encapsulate 34. We encapsulate only the name, the George. But I would say that we actually encapsulate 34 too, because it's inside an object. It's hidden from the outside world. So whatever happens inside is encapsulated. How it's generated, it's a different story. So the main problem is to define the surface, to define how what the object is. And most people make mistakes at this point. Most of us are making objects too open. We're making too big objects. We let other entities, other objects, other pieces of code to access the information from the object. For example, I can say here name, and I can say here name equals, which is a setter. And then I will be able to say name equals n. And here I can say user Jeff, and then I say name Peter. I make an object with this setter. This is how you define setters in Ruby. So with this approach, I'm not sure this is the right syntax because I never use setters, but I think this is how it works in Ruby. So we make it. Now I made my object more open to its neighbors. Here's the neighbor. This is the neighbor. This code, it's not a class. It's not inside the class, inside another object, but it is a neighbor code. And now this code can get access to the internals of the object. It can say that now I can access the attribute. Now I know what you encapsulate. With this line, I know what happens inside you. I know how the object user is designed. I'm not only aware of the surface. I'm not only aware that the user has a name and an age, and I don't care what's inside. But now I know that there is an attribute, and actually the name is encapsulated, technically encapsulated inside the attribute. I won't be able to do it this way anymore. Because somebody, I can't do it just looking at this object, just looking here. Because I don't know, looking at this method, I don't know who else, how many more neighbors made an assumption that the name is encapsulated. And because of that assumption, are using the setter. I don't know how many of them are out there. And that's why I can't afford to redesign the methods. I have to stay with this stuff. I have to stay with this getter. So the way I encapsulate data should not be visible. The way I work with the data should not be visible. The way I design my methods and the way I interpret data and the way I manage data, it's all my job. It's all inside me. It's all inside an object. And the moment you allow somebody from outside an object to know what's inside, that's how you start ruining your design. That's how you start making your code less readable, less maintainable, less elegant. Because, like I said, because of this problem, because the more you open your object, the more assumptions will be made by its neighbors, by other objects, by other pieces of code. They will know what's inside you and they will make those assumptions. They will touch your internals. And in the end, your objects will be wide open, containing some pieces encapsulated, some data encapsulated, and whoever stays outside of that code will be able to touch that internals. In the end, you will not have the core benefit of object-oriented programming. I'm getting to my point. The core benefit of object-oriented programming, in my understanding, is lowered complexity because of encapsulation. We lower the complexity because we make our code, our objects, less open, more closed, less visible, less transparent, more like black boxes. That's how we decrease complexity. We make it easier to understand the whole code. Because when I look at this code, this is one level of complexity. Here, when I'm looking at this code, like I said before, I cannot make a decision just looking at this class. Who is connected to these methods? And moreover, who is touching my name and what they can store there? Can they, for example, in Ruby, it's a weak language, so there's no typing. So there could be a number in there, could be text in there, could be some object in there. I don't know. I don't control it here. And if I put the control, if I say if n is a string, I don't know, raise, wrong name. So if I put this border condition, then I don't know in how many places of my code that will crash the execution. If I'm lucky enough and I have full test coverage, maybe it will throw an exception during the build process. But in most cases, the test coverage is not 100%, and some of those calls the calls like this will not be covered by unit tests. And in production, that line will throw an exception. Just because I decided to refactor the code and introduce some extra validation. So it means that the complexity is high here. The complexity of this code is high. It's higher comparing to, making it this way. I'm not allowing anyone to touch my, I put it here, and I'm not allowing anyone to touch my name later. And if, for example, okay, in this line you may say that what did I change because I moved it from one line to another. But what if I say in the future that instead of returning the name from memory, I would like to load it from the file? I don't know, somehow. That will be completely impossible to do or very difficult to do if I allowed someone, some unknown entity, to touch my internals. So the closer the object, the more protective it is, the more defensive it is, the more it fights for keeping its borders not crossed, the better for everybody. The more it looks like a black box, which nobody can penetrate, nobody can break, the better for the designer of that object and for designer for the entire application. If your application is constructed from objects which look like black boxes and you just combine them and they interact through their surfaces, then the code is really highly maintainable because you can always look at one problem at a time. When you look at one piece of code, one object, you deal with one problem. You know that nobody else actually had access to any internals of it through setters, getters, and whatever you call it. Not only setters and getters. You can introduce many other methods of touching the internals. No matter how you no matter how you no matter how you design your code, just think that it has to be that your internal design should not be visible to the outside object. Nobody should know what's inside. They may not have any assumptions about what happened inside the object. This is my the introduction, the philosophical point, and now getting to the global variable. So what is a global variable? Let's say we have a user and we want that user to have a name, or let's say not a name but a picture, an avatar. What do I do here? I say, look, yeah, I don't even know how to use global variables, but let's assume this is global variable and let's call it avatar, just a global variable, and call it users, no, user, I don't know, user GIF, and then we use avatar. This is a classic example of, and then we say user new, and then I have user avatar. Let's rename it. Let's make it even worse. So this is the classic example of a global variable. I have a class user, it needs to return the avatar, but I define the location of the avatar somewhere else, which is on the global scope. I don't really know why people are doing that. I can't really find the good reasons, but it happens. It happens, and most likely I don't know why the 50% of my readers said that they want global variables. I don't really know the reason, but let me try to improvise. Maybe they have static methods, but even for static methods, I don't know, but it happens. So people do define global variables which stay on the global scope of the entire application. So this file is going to be visible for all objects in the applications, all of them. Maybe, okay, here's the reason. So maybe sometimes users may say, developers may say that, let's say we have a database, or we have a console, or we have something which is, which is supposed to be visible for everybody, for all objects in the code, because we don't want to pass that variables to each object. We don't want to, every time we instantiate an object, we always will have to pass some parameters to its constructor. But what's the point if all of them will need the database, for example? So the database is supposed to be accessible by users, by files, by documents, by all possible controllers, models, whatever. Maybe. But let's see what's going to be, what is the problem here? The problem is that philosophically speaking, the problem is that now our object is broken down into two pieces. Instead of having an object which is, like I said, is a black box and it cannot, and nobody knows how it works. Now, staying here, we know how it works. We know that by changing this variable, and in Ruby you can do that, you can say file equals to, this one, then we affect the behavior of this method. So we know how the code works. We know how the object is designed inside. We can have that assumption. We can use that assumption, that information, to make an assumption that by changing that file, the behavior of the method will change, and it will change. It will change and it will work. But what's gonna happen when the designer of that class will show up and will decide to redesign it and change the behavior inside it? That person will not know in how many places we did that. Well, they will be able to search the code and maybe potentially find those places. But that will take time, and that will seriously affect the complexity and maintainability. So we are basically breaking the code into pieces, into two pieces in this case. So on the conceptual level, on the theoretical level, we are just, by global variables, we are increasing the complexity by breaking objects, by tearing objects apart and opening them. We just opened our object. We made it depend on something which an object does not control. Did I make my point clear? Yeah, that's what I wanted to say. So the object is not a black box anymore. It depends on something which is changeable from the outside. Well, you may say that even if we encapsulate it here or pass it to the constructor, then it will be possible to change it somewhere else. Well, potentially. Yeah. Anyway, let's go to the technical problem. So theoretically, the key point is that objects are not supposed to be open and editable and controllable by any mechanisms which go outside of their control. So we always want to communicate with an object when we want that object to do something for us. We don't want to make the maybe I'm a little bit wrong here and not very specific about the control, because you may say that if we encapsulate the variable file here and then we change the variable somewhere else, for example, let me show you. So let's say we have f here and let's say it's not f but it's some object f, and we say f equals to f, and then we read, for example, file pass. So here when we encapsulate that, we say let's say I don't know, some other type, I don't know, holder. And then I say f move. See my point, right? So here I encapsulate some f, and then when I encapsulate it, it's pointing to one direction, and then I say, okay, move it somewhere, and it moves, and then I say avatar, and obviously here at this point the behavior will be different, because here it will load xgif instead of usergif. So it's not about controlling, because user cannot, the object cannot, our object user cannot control everything which is happening with the stuff it encapsulates, with all the dependencies. But so it's not about control. I just explained you that I was a little bit wrong about saying control, but here the object is pretty solid, and the object, the internals of the object, the way it works with its dependencies, is not visible to the outside world. And by visibility, that's what I said in my blog post about global variables, is that the biggest problem they introduce, these global variables, is that they make the scope of visibility way larger than just one object. So when you look at the object, you just see one object. Or when the object depends on some global variables, you need to see them together with the object. You need to keep them in mind when you refactor the object, when you deal with the object. You need to remember where they are located, and like I said, who is using them as well, who is touching them aside from your object. So your scope, which you deal with, your problem scope, is way larger when you have global variables. or when you have singletons, or when you have static variables. It's the same, static attributes. So singletons and static variables are exactly the same as global variables. They just look a little bit differently, but technically, technically they are different a little bit, but conceptually they are exactly the same. They are just like global variables. They make the scope way larger, because the moment you start touching something global, because here it's not global, this f is not global, the f is pretty local. It comes to me, and I know for sure that that who gave it to me is the place where that variable can be modified or can be touched. But when it's global, I don't know who is touching that variable. I need to go through the entire code base and look for places which is touching that global variable. So my scope, which I need to deal with, is way bigger, which means the problem for maintainability, because it requires me to think more, to keep more things in my brain, to remember more things. And this is what makes our work difficult as programmers. We don't want to remember many things. We need to remember as little as possible, ideally, especially when you work with multiple projects, like I do. I don't want to remember how my code works. I want to, I want to finish working with it, commit it, push it, and forget it. And then go to the next piece. And then again, modify it, run the tests, make sure it works, or make sure it doesn't work, I don't know, and then commit, push, and move on. So remembering how the code works, and especially remembering big scopes, large scopes, which include multiple global variables, singletons, or static attributes, is a more complex task. And it will require more time when you get back to your code. When you open your code in a few months, if there are global variables, you will need to remember the whole story. You will need to remember who is touching them, where, and what are the connections between your objects and other objects which are also relying on that global stuff, on that singleton, for example. We say, okay, it's a singleton for the database connection. So who is touching that singleton? We don't know. Who is creating that singleton? We don't know. That makes the code less isolated. Maybe that's the word I didn't mention so far, but this is another interesting word. It's isolated. So the more we isolate our problems, encapsulate or isolate, probably it's very close meanings of these two words, the better. The smaller the object, the more isolated is the scope of problems it solves, the better. Smaller objects are better objects. And by smaller, I mean not the amount of lines, which is also a good metric, but this is not what's important. What's important is the amount of entry points. The more methods you have, the larger the object. I have a few objects in my code which are quite small, but they have multiple methods. I can show you it here. For example, the ID. For example, this is a pretty small object. Maybe it's not the best one. This one. Look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. 22 public methods. This is a terrible design. It's my design. But I don't like it. I made it because I was I was experimenting. I didn't know how to do the right design. But 22, it's horrible. This is not what you're supposed to do. 22 methods, it's way above the line, and the acceptable, tolerable line. 5, 4, that's the number you may have. But you saw that the size of the code is not really big. I mean, the amount of lines. There was like maybe, 100 lines, including the header. Well, 190, including 2 private methods. So less than 200, about 200 lines of code, including the pretty large, these these text and these comments, and there are a few comments. So there are 200 lines, which is not a large file, but 22 methods is way above the line. So what's important is how many methods you have, how many entry points, public methods. With the constructors, we had another webinar for constructors where I mentioned that constructors are okay. Large amount of constructors, it's a perfect it's a perfect design, because that's how you allow other objects, your neighbor objects, to start working with your object. How they, how they instantiate your object, and how they use it to compose bigger objects. That's fine. The more constructors you have, the better. But then the way they interact with an object has to be, those ways have to be very limited, as much limited as you can. Okay, a few more technical concerns about global variables. For the tests, of course, it's global variables. They make your code way less testable, sometimes even not testable. In Ruby, it's not multi-threading. It doesn't run tests in multiple threads. But in Java or many other languages, you do want to run your tests in multiple threads, just to make your build faster. And then you won't be able to do that, because if your code relies on some global variable, then of course you cannot run the test which will do this, and then another test will do, I don't know, something like, I think I'm saying obvious things, but I have to say them. So you cannot do this. You cannot run these two tests at the same time in parallel. The first test will use one file. The second test will use another file. If they go one by one sequentially, everything is fine. But if you run them in parallel, then you don't know what's going to happen actually inside the method avatar. Which of them will definitely fail? Maybe both of them. And it will be very hard for you to understand why they fail. In this particular example, the code is simple. You will find the reason. But if the code is large and you run it once and it passes, and you merge everything and then you put it to production, and then tomorrow your build fails, your build doesn't pass, and you don't know what's going on. It sporadically, randomly, unexpectedly fail because your tests deal with the same global variable, or the same singleton, or the same static attribute, and you don't know when they clash, when the multiple threads, different threads clash at the same point. Well, you can disable multi-threaded testing, of course, but you will lose the performance of the build, and you will hide the potential production problem, because that the failed test is a good thing to have. The more stable are your failures, that the more aggressive your tests are, the more aggressively they fail, the better. Good tests are the tests that strongly fail. If you really change a little bit, if you really design the code in a bad way, not in thread safe way, if it's supposed to be thread safe, then a good test will immediately catch that and immediately fail. In that case, if your tests are not strong enough, then you will have the problem with the concurrency. Well, the second problem is side effects, of course, so which may happen in your code even without the multiple threads. You may have this line, and then you say avatar, and then somewhere somebody says this, and then you call avatar again. So this one will happen somewhere in some other place of the code. So you will never know why the avatar returned one file and then here it returned something else. It will look to you that you didn't, for example, I don't know, you will call some, and here in foo, I don't know, in some method, that will happen. So you don't expect that to happen. When you run this method, you don't expect this file to be modified. But if you look at this code, and this one is gone, if you just look at this code and see, look, user, file is test2, then avatar, it's good, then you run this, you don't expect the file to change, and then you call this again, and boom, it's a different file. This is called side effect. Well, I think this is called side effect. It's a side effect of this method. So you call it, and instead of, well, on top of doing something which is supposed to be happened there, it does something which is not an expected behavior. It changes the global variable. And then all of a sudden, here an unexpected behavior, it's a different avatar for the user. And then you will have a lot of that stuff here and there everywhere. Again, it will be very difficult to test. It will be very difficult to understand where the problems are. The complexity will be high. When you can't understand something with your code, it means the complexity is high. It means you're a bad programmer. It means you created something which is difficult to read. This is how you define who's a good programmer, who's a bad programmer. A good programmer writes code which is easy to understand for that programmer, for everybody else, for a junior programmer who just joins the project. This is who is a good programmer. The programmer who writes code which is easy to modify, easy to understand, easy to rewrite, easy to test. A bad programmer writes code which only that programmer knows how it works. It's difficult to test, it's difficult to maintain, it's difficult to modify, it's difficult to read. Because it's cryptic, it's unclear. That's the definition of a good and bad programmer. So if you want to be a good programmer, you don't do global variables ever. Every time you want a variable, you need something for your class, you make it come to you through the constructor or one of the methods. You never rely on something global. And the last point, why it's not good to have global variables, is that it's difficult to reuse an object. It's difficult to use it here and then use it somewhere else, because they will always touch the same piece of data, and you will not know which one is doing it first. So here it's all clear because we have one user. What if tomorrow I want to have many users? Here it will be obvious for me. If I want to have many users, I will open the class user and will look and say, okay, it uses the global variable. Something is wrong. I need to refactor it somehow so that the location of the file is passed through the constructor. But if the class is large and it uses global variables here and there, where you don't know exactly where, and then and it's expected to have just one instance of this class, and then you decide tomorrow or in a year to create another instance of this class or have multiple instances of that class, it will not be possible. Or, which is even worse, it will look like it's possible, but in production it will cause problems. You will start using it, you will deploy it, the tests will pass, or there will be no tests, and then you will see the problem in the future. So that's probably the most important technical problem with the global variables, is that it's difficult to multiply objects. It's difficult to make series of them, to make many of them. This is pretty much what I wanted to say. Now let me look at your questions. One comment is globals aren't actually global, they exist within the body of the application. That's exactly my point. So yes, they exist within the body of the application, and the scope of the application is large. You don't want to deal with the entire scope of the application. Yes, the application is a huge something where you have everything alive. All your objects live there and global variables. You don't want to deal with that scope. It's a very scary territory because it's large. You want to deal with something small. But global variables force you to deal with the global scope. Another question. The reason you would do that is to avoid code duplications when many classes use the same resources. That's probably the most popular reason for global variables. Programmers say that we want something global because we don't want that entity, that object, to go through other objects every time and be encapsulated inside constructors. I would still say don't do that. Still encapsulate, still pass that stuff into constructors. Like I said, for three main reasons: testability, reusability, and side effects. Even if it looks to you that this is the database, so what else may happen to the database? It's always global. We have one database ever. No, tomorrow you will design unit tests where you will need multiple databases. You will need two databases to test how your code works with this structure of data and then how it works with another structure of data. And you won't be able to do that. So never ever expect your object to depend on something which exists only in one instance in the application. Objects are supposed to be duplicated, copied. Objects are supposed to be, we're supposed to have multiple of them. This idea of one single object forever, we only have just one thing which is forever, which is an application. So application, it exists in one instance. Everything else may exist in multiple. Even the application may exist in multiple instances. Again, for unit tests, you may create another instance, another instance, another application. With singletons, one of the most annoying problems is not always knowing in which order they are initialized. If they depend on each other, it's very easy to break the initialization order. Well, here we're speaking about probably the dark side of dependency injection, where objects are created by some dependency injection container with some logic inside, usually defined by annotations or XML configuration files. And then, yes, those frameworks like Spring, for example, they just in some order they create objects when the way they want that, and then give those objects as singletons, as instances with one copy to our code. Well, that's a terrible practice. I would suggest to stay away from any dependency injection frameworks and always instantiate objects with the instantiation operators like new in Java or new in Ruby and all that stuff. Because when you hide the moment an object gets born, you lose not the control, but you lose the idea of how your application is designed. We had a few webinars for that as well. Try to look for DI frameworks or just dependency injection. You will find my opinions about that. What's your opinion on Clean Architecture by my Uncle Bob? Have you tried it? Clean Architecture. Is it like something specific, or is just a set of recommendations for? Because I like the book Clean Code by Uncle Bob, definitely. It's quite old, but pretty good. Yeah, I'm not sure I know. I haven't read the Clean Architecture yet, but I'll try it. So the big problem you're referring to is changing things which are not expected to be changing. Well, most likely yes. Most likely yes. So everything is supposed to be changed, and the good developer expect that to happen. Expect that to happen, maybe not now, but in the future. So we have to design for the future. We have to design for further developers, for developers who will join the project after us. Maybe when we quit the project and we're not with this code anymore. So we need to design for that future generations. And we never know where and how they will use our stuff. We need to design stuff. We need to design objects for reusability. We need to look for reusability opportunities. We need to give them the ability to reuse our objects, not to stick to the way we expect them to use our objects, but improvise, experiment, compose, reuse, retest, whatever. And you cannot achieve that if you have something static, if you have something global. It's just unachievable. You just lock yourself and your future partners and your future colleagues and developers to one specific architecture. And this is not how software development should be developed now. This is not how programs live anymore. We want to reuse. We want to make them small. I'm not saying microservices. I'm saying micro modules. We want to have our code to design in micro pieces, which we can take from here and there, preferably open source, preferably composable at the level of modules. So that will be ideal, when I can just take a module, import it to my code, and boom, I have a database, and then boom, I have a storage for files. I don't know, and then I have a set of algorithms, and then I have some calculator or whatever. And all of those pieces are open source, composable, reusable, as packages and as objects. That's the ideal design for an application. So monolithic applications where everything is connected together and stayed together through global variables or singletons or static attributes, it's the past. The future looks different. In the future, we want to be able to retest whatever it is and reuse whatever it is. If you use global objects only with getters, for example, for configuration system, that's another question. But I think I just answered it. That now you want it with the getters only, but tomorrow you will want to somehow fake the configuration system in the unit test, and then you will need not maybe getters, not maybe setters, but you will need to have an ability to make a different instance of that object. And you won't be able to do that because it's global and everybody depends on it global. So try to make everything lightweight and flying through the application instead of staying in one piece. You never know how your application will look in the future, how big it's going to be, and how many more composition opportunities will show up. Okay, one last question. Uncle Bob's Clear Architecture is a specific architecture, and the name of the book, which talks about general principles, not just the one from point number 1. I will take a look at this specific architecture. I can't say I'm an expert in architectures, to be honest. I think at the level of the architecture, there are way more areas for experiments and for different designs than on the level of objects and methods and classes. So for the architecture, I don't know. I haven't found in my career any explicit instructions or explicit recommendations for how to design the architecture. On my blog, I have almost 300 articles and not a single article about the architecture. So I never recommend how to design on the level of packages and systems and subsystems, because I don't have anything to say. I just don't know how to do it. In every specific case, it's a different design. So I just don't know whether we need there any specific recommendations. Even this microservices trend and monolithic applications, sometimes we need microservices, sometimes we don't need that. I cannot recommend there anything. So for the architecture, I'm not sure I can actually say anything. Here's the comment. If a project is trying to write code which can be reused in different contexts, then it makes sense to avoid globals. That's true. And my point is that most objects or all projects, most projects or all projects have to be designed with this mindset. Potential reusability by we don't know who, where we don't know. If you design it that way, you will make a good favor for yourself and for everybody around your project. Just design it for reusability, for very flexible reusability. So that was all of my points. Thanks for listening. That's it for today, and see you next month. We have webinars every first Wednesday of the month at 11 in the morning Pacific time. Thank you. Bye-bye.